This question is about the intersection of two circles. That's how we're going to find point A and B so that we can then show that the angle AOB is 0.635 radians. Because I can create a little triangle using AB and the lines going to the radius. This radius is going to be 10 because remember it's x, well, the general formula of course is x minus a squared plus y minus b squared equals r squared. So I've got a radius of 10 here and a radius of root 40 here. Okay, if I want to find out a and b then, I need to essentially set the, well, not set the circles equal to one another, but it's like somehow substitute in. So I'm going to take C2 and expand the bracket, then I'll get x squared minus 30x. Remember, this is a double bracket, x minus 15 times x minus 15. You get two lots of minus 15x plus minus 15 times minus 15, which is 225. So when C1 and C2 intersect, it must be that both equations are true at the same time, which means that x squared plus y squared is going to be 100. And I can just replace this here by 100. So that will give me 325 when I add the 100 to the 225 minus 30x is equal to 40. That means 30x is equal to 285. And if you do 285 divided by 30, then we get x equals 9.5. So that's the value here for both of them, of course, because it's a vertical line. We're going to get two different y values. I'm going to need both. So I'll put it back into the x squared plus y squared is 100. And that will give me 9.5. Wait, I'll just go straight for actually. Y squared will equal 100 minus 9.5 squared. (39/4). So then it's plus or minus the square root of that, which is root 39/2. So point A is going to be 9. I know I've left it as this one as a fraction, the other one, sorry, this one's a decimal, the other one's a fraction. It's okay. 9.5 root 39/2. And then down here, 9.5 minus root 39/2. Okay, I've got one last little thing to do then, and that is to just consider this triangle. I'm just drawing it away from it, but it's this triangle here. The lengths here are going to be 10 and 10 because that's the radius of the circle, which means we have an isosceles triangle and it's going to be a line of symmetry going through it. So if I want to find the angle AOB, that's all of this, I can just consider the top triangle and use normal trigonometry, right-angled trigonometry. So this is 10, and this is going to be root 39/2, because that's the distance from here to here. That was my y coordinate, root 39/2. So let me call this x. Then it must be that sine x is equal to root 39/2 over 10. And then I can do inverse sine of that. So actually it's going to become root 39/20. Okay, we get 0.3175. And therefore angle AOB is going to be double that because I've got two lots. Zero 0.63512. or 0.635 radians. Brilliant. Another option, if you don't spot to split it into two, is to use the cosine rule. It's a little bit more involved, but you'd have this as root 39, and then you've got your side opposite the angle, and just apply the cosine rule. I'll just quickly show you actually. So it would be root 39 squared is equal to 10 squared plus 10 squared minus 2 times 10 times 10 times cos of the angle AOB. Okay, and then just rearrange that, do inverse cos, and you'll also get the 0.635. So an alternative, but this is definitely a slightly quicker approach. We're now asked to find the perimeter of the shaded region, giving our answer to one decimal place. So we're going to consider each circle separately, and I'm going to start with the green one. I think I'm going to go straight for it, and then we'll deal with the other one. It'll be a similar sort of method to what we've done before. Because what we have is the center here, and we've just worked out the angle as 0.635, although I'm going to use the exact answer. And I can do 2 pi, which is equivalent to 360 degrees, minus that to get the angle inside the sector. So 5.6480. It's 2 pi minus the 0.63512. Then the arc length is given in radians just by r theta. S equals r theta. Let me just remind you where this comes from. It comes from finding the circumference of a circle, 2 pi r, and then times in by the fraction of the circle that you have, theta over 2 pi in this case. We have an angle theta, the whole angle is 2 pi, and these just cancel out, leaving us r theta. So it's just going to be 10 times 5.6480, which is going to become 56.480. So that's that green part done. And we're just left to work out the orange part. Now, it's guided us. It's going to be a similar process. We first of all need to find the angle inside here. Let's draw the triangle out. Now the radius for the second circle was root 40. Going to split the triangle into two again. Still isosceles, that's also root 40. This is still going to be root 39 over 2. I call this angle y. Then I've got sine y is root 39 over 2 divided by root 40. It's going to be very close to a half, but slightly less. Again, you could use the cosine rule, but this approach, if you can spot it, it's going to be a little bit quicker. And then I'm not going to write down what that is. I'm just going to go straight for it. Inverse sine gives me 0.51635. Remember, that's just half of the angle that we're interested in, so I just need to double it. 1.0327. So that is angle, okay, this isn't given a point. Let me call it X. Angle AXB. So I'm very nearly there because now I've got this bit. I've got the radius, remember, as root 40. Just want to work out this angle, which is going to be 2 pi minus 1.0327. Gives me 5.2504. And S will be root 40 multiplied by that. Gives 33.206. and we're nearly there. So the total perimeter is these two added up together. And if you figure that out, it becomes 89.686 or 89.7. Okay, I think that question is quite challenging personally. Simultaneous equations with circles, you get the coordinates A and B, then realize to draw a triangle and either use cosine rule or split it up into two, get the angle, all that work to get it. Work out the perimeter or the green length basically. Do all the same process with the orange one. I guess you're repeating it. So once you understand part A, it's the same approach, but like part B kind of requires you to understand it really. And then yeah, use the arc length formula and everything, and we're there. Okay, good job.